Today we will be solving this equation, question number 4.11. It says that the following results have been obtained during the kinetic studies of the reactions. 2a plus b gives c plus d. Okay, so there are four experiments, and initial concentration of A has been given, initial concentration of B in terms of mole per liter is also given, then initial rate of formation is also given, right, for the four different experiments. For the same reaction, okay, now you have to determine the rate law. You have to determine the rate law and then the rate constant for this reaction. Now we will solve this equation. So solution is 4.11. Experiment number 1. Okay, before that we know that rate is equals to k. Here is given a to the power x, b to the power y. This is the rate law expression, right? So in the first one, the rate is given, that is initial rate is given as a 6.0 into 10 to the power minus 3 mole per liter per minute. We'll do not write this one. So K and A, the concentration of A is given as 0.1, and we don't know this factor. We'll just write X, and B value is given as again 0.1 concentration of B, and we don't know this factor Y. So this will be your equation number. Okay, we'll put it 2. This is equation number 1. Similarly, experiment number 2 implies 7.2 into 10 to the power minus 2 is equals to K 0.3 to the power X 0.2 to the power Y. Okay, equation 3. Similarly, experiment number 3 implies 2.88 into 10 to the power minus 1 is equals to K 0.3 X 0.4 Y. Question number 4. Experiment number 4 implies 2.40 into 10 to the power minus 2 is equals to K 0.4 to the power X 0.1 to the power Y. Equation 5. Okay, so according to the question, you have to find the rate law. Okay, determine the rate law. So that means you have to fill all these terms. You have to find and the rate constant. So you have to find K, and you have to find the value of X and Y. Okay, in the question. Now we have to solve for this. We have 4 equations, and we have 3 unknown factor x, y, and k. Right. So we'll look at the similar values first here. Okay. So 0.1 and 0.1. Okay. And okay. So we'll do it. So equation 5 divided by equation 2, we get by, okay, dividing equation 5 by equation 2, we get, so we'll keep this up. So 2.4 is 0 into 10 to the power minus 2 by 6.0 into 10 to the power minus 3 is equals to, because this left hand side divided by left hand side, right hand side divided by right hand side, K 0.4 to the power X 0.1 to the power Y by K 0.1 to the power X 0.1 to the power Y. Now these are same values, so we can cut, right? Okay. So if I remove this one, then it comes as 10 to the power minus 1. So I'll just rearrange this. 24 divided by 6, okay, 0 has no importance, into 10 to the power minus 3 by 10 to the power minus 3 is already there. So I'm shifting point is here, so 10 to the power minus 1, so I'm changing this to minus 3. Yes, okay, k is also, so if So what we can do is 0.4 by 0.1 whole to the power x we can write, right? So your cartons are 616, 6 4 are 24. So 4 is equals to, here comes is a so 4 by 1, so 4 by 1 means 4 to the power x. So by comparing, this implies, so I can write here 1, this implies x equals to 1. Okay, so we got the value x. Similarly, now look at this equation. So any same values? Yeah, these two have same values, right? So we'll just divide this by this. So by dividing equation by equation 4 by equation 3, okay, we get, so 2.88 into 10 to the power minus 1 by 7.2 into 10 to the power minus 2 is equals to k 0.3 to the power x, 0.4 to the power y by k, 0.3 to the power x, 0.2 to the power y. So again this, okay. So here also we have to say we will cut it by 2, 2 1 2 3s are 6, 2 6 are 12, 2 1s are 2, 2 4s are 8, 2 4s are 8, so 36, again 2 1s are 2, 2 2 is a 16, 2 7s are 14, 2 2s are 4. Okay, now we'll put here 0, so we'll just release this one. So but here is a minus 1, so we'll be getting 72, this implies 72. Okay, we'll got it here. Okay, so after all this reduction, so we get 4 here, so here comes 2 by 1, so it's a 2 to the power 1. So 4 equals to 2 to the power y, so we'll just rearrange here. We'll just write 2 to the power 2 equals to 2 to the power y. This implies y is equals to 2. Okay, so earlier we got the value x equals to 1. Now here we got the value x equals to 2. Now we have to find the value of k. So value of k. So you can put in any of the equation, these 4 equation. You put the value of x equals to 1, value of y equals to 2, then solve for the k, and you will get the answer. Okay, I have done the calculation here. So putting the value of x equals to 1, y equals to 2 in equation 2, we get, so 6.02, 6.0 into 10 to the power minus 3k, 0.1 to the power 1, 0.1 to the power 2. So this k equals to, okay, so we'll just rearrange it, 1 2 3, so 10 to the minus 3, so this cuts k 6, k equals to 6. But we should know the what is the unit, right? So for unit we know that is x equals to 1, y equals to 8. That means n equals to x plus y, so n equals to 2 plus 1, sorry, 1 plus 2, so this gives 3. Alright, so we have the formula to determine the unit of rate constant. K equals to mole per liter 1 minus n per minute. Minute we have taken because the equation is given minute, right? Otherwise normally we do in the second. So after putting the values here 3, here we get this relation, so we put this equation. So this is your answer.